What if you could predict a product defect before it ever even happens? Well, that's what we're diving into. We're going to explore how a set of powerful new technologies, what everyone's calling Industry 4.0, is completely rewriting the rulebook for quality in manufacturing. Seriously, this is a huge shift, moving from just preventing problems to actually predicting them.
So why does this matter so much? Well, for manufacturers who are kind of stuck in the old ways, a staggering 5% of their total revenue is just gone. It's eaten up by what's called the cost of poor quality. We're talking scrap, rework, recalls, all the bad stuff. Now, get this. The industry leaders, they've slashed that number down to about 1%. That means subpar companies are literally paying 5 times more for their mistakes. The stakes, they couldn't be higher. For decades, the answer to managing all this has been a set of 5 methods known as the core tools. You really can't overstate their importance. These are the essentials, the absolute backbone of quality management, especially in huge industries like automotive and aerospace. Their entire purpose is to prevent errors from happening in the first place, not just catch them at the end of the line. And here they are, the big 5. You've got APQP, which is all about designing quality into a product from the very start. Then there's FMEA, for proactively figuring out what could go wrong. MSA, make sure your measurements are actually accurate. SPC is for watching and controlling the process in real time. And finally, PPAP, which is the final stamp of approval on a part. For years, this has been the gold standard, this interconnected sequence that takes a product from an idea to a reality. But there's a catch. This whole system was designed for an analog world. Which brings us to the big question, right? How effective can a paper-based analog rulebook really be when our factories are getting smarter, faster, and more connected every single day? The traditional way of doing things, well, it's just riddled with challenges. So much of it is manual, which means it's slow and, people make mistakes. And here's the crazy part. Mountains of valuable measurement data just get thrown away after a simple pass or failed check. All that insight is lost. This forces companies to be reactive. They're always putting out fires, fixing problems after they've already happened. And all of this creates these massive bottlenecks, especially when it's time to validate a brand new part. And this is where the upgrade comes in. Industry 4.0 isn't just some buzzword. It's a whole suite of technologies that directly fixes these old-school limitations. It does it by connecting what's called the digital thread through the entire manufacturing process, from start to finish. So what's actually making this transformation happen? It really comes down to 4 key pillars. You've got the Industrial Internet of Things, or IIoT, and smart sensors. Think of these as the factory's nervous system, constantly collecting data. Then you have artificial intelligence, which is like the brain, analyzing all that data for patterns nobody could see before. Digital twins are next. They're basically virtual replicas for testing and simulation. And it's all held together by cloud computing, which gives everyone a single source of truth to work from. Let's look at how this totally transforms the tools. Take FME, the risk analysis tool. It used to be the static document, basically a best guess based on past experience and what people remembered. Now, it's a live predictive tool. AI algorithms are constantly analyzing real-time data from the machines and can actually flag a potential failure before it ever happens. The shift from just theoretical to truly predictive it's just massive. And you see the same revolution happening with measurement systems analysis, MSA. The old way involved these manual studies that were a huge bottleneck. And honestly, the results could change depending on which operator was taking the measurement. Now, you have automated scanners and coordinate measuring machines that completely remove that human variable. And it gets even better. AI can even monitor the health of the sensors themselves, detecting if they're drifting out of spec in real time. Okay, this brings us to one of the most powerful concepts in all of Industry 4.0, the digital twin. And let's be clear, this isn't just a 3D model. It's a dynamic, living, virtual replica of a real-world product or even an entire production line that is constantly being updated with live data from sensors on the factory floor. And here's the magic of how it works. You have this constant automated flow of data from the physical thing, the real space, to its virtual counterpart, the virtual space. In this virtual world, engineers can run all kinds of simulations. They can test different what-if scenarios and validate a whole process without ever touching a physical part. It's like having a perfect, risk-free test lab right inside your computer, which allows you to get things right the very first time. Of course, making this huge transition, it's not as simple as just flipping a switch.
the path to building a truly smart factory is definitely paved with some pretty significant challenges. Yeah, companies face some common hurdles. The initial investment can be pretty high. Trying to integrate shiny new technology with decades-old legacy machines is a massive technical puzzle. There's often a shortage of people with the right digital skills to manage these new systems, and frankly, sometimes there's just cultural resistance. People are used to doing things a certain way, and change is hard. So, how do you get past those roadblocks, especially the one about old equipment? Well, it all comes down to having a clear strategy. First, you start with an audit to see exactly what you're working with. Then, companies can use something called middleware. It's basically special software that acts like a translator between the old machines and the new platforms. And finally, you don't have to do it all at once. Starting with a small pilot project in one part of the factory lets you test, learn, and prove the value before you go for a full-scale rollout.
Okay, so with all that effort, is it actually worth it? Oh yeah, the results from companies that have made the leap are, well, they're pretty clear. The real-world results we're seeing are just staggering. I mean, we're seeing companies across the board, automotive, medical tech, logistics, you name it, achieving these incredible gains. From automating their quality planning to using AI for visual inspection, the outcomes are always these dramatic boosts in efficiency and just massive cost savings. Let's just zero in on a couple of these. Avaline Technologies saw a 40% increase in what's called overall equipment effectiveness, or OEE. That's a direct measure of how much of your manufacturing time is actually productive. A 40% jump is an absolute game changer for getting the most out of your assets. Then there's the bottom line, $2.3 million. That's what Super Auto saved. And how? By automating their APQP process. They took what was a slow, manual, paper-heavy process and turned it into something streamlined, digital, and just vastly more efficient. And this number, this one is truly transformative. That same automation led to a 93% productivity boost at Super Auto. That's not a small improvement, right? That is a fundamental change in how they operate, and it frees up their engineers to focus on real innovation instead of just shuffling paperwork. So when you put it all together, what does this mean for the factory of the future? It's really all about creating a powerful new synergy between those timeless quality principles and today's cutting-edge technology. And if there's one thing to take away from all this, it's this right here. This isn't about replacing the core tools. They still provide the essential logic, the why behind quality management. Industry 4.0 simply provides the how, and it does so with a level of speed, data, and predictive intelligence that was literally impossible just a few years ago. This entire evolution is leading us toward the idea of dark factories, these highly automated environments that can run with the lights off. In this future, human work really shifts away from the routine stuff, like monitoring and control, and moves up towards high-level strategy, system design, and optimization. And that leaves us with a final, really fascinating question to think about. As our factories become more and more automated and self-optimizing, what becomes the new role for human ingenuity? What are the next big problems for our creativity to solve?